Okay, we're going to be looking at chain rule. We're going to be looking at chain rule for differentiation. We've done the part one, I think, as 2 days ago. So if you missed that part one, please check the channel for the beginning part of this chain rule. Today will be continuation. Today will be continuation of the previous section. We have find the y, the x of the following. We have the first one, second one, third one, fourth one, and fifth one. Okay, we're going to start from the let's start let's start from 3, 4, and 5. When do we use a chain rule? When do we use a chain rule? In the last previous video, I said chain rule can be as you're coming in, begin to say I. Okay, I'm going to repeat this second one. I'm going to repeat this one again. I'm going to repeat this one. I said, let y give this base a letter. You can call it t, and that'll be t to the power what? To the power 10. Where t is equal to what? 2x plus 1. So we can get y is a function of t, and t is a function of what? Of x. So we can get the y, the t, differentiate this y respect to this function, and that will be 10t to the power 9. T is a function of x, so get the t, the x. If you differentiate this one, you're going to have what? 2. Okay, then your dy, because your y is a function of x, so your dy, the x is equal to what? The y, the t times the t, the x. So whatever you have here must be the same with this one, and then you make your substitution. That will be 10t to the power 9 times 2, and that's 20. 10 times 2, 20. Your t is an expression 2x plus 1 power 9. So that's that for that case. Let's start from number 3. Question 3. We have y equal to what? 2x minus 1 to the power 5. Okay, the fastest way, or the faster way to solve this question, your y is a function of x, so your dy dx will be equal to what? The power will come to the front, then the expression, the power here minus 1, making 4, and then times derivative of the composite function, derivative of the base. Okay, and that will be what? 2x minus 1. So if you differentiate this one, you're going to have 2. So that will be 2 times 5. That's a 10. 2x minus 1 to the power 4. And that finished that solution. Number 3 is done. 3 is done. 3 is done. Please invite someone. And if they are new to the channel, subscribe straight away. If you are new, subscribe. If you are a returning viewer, begin to share the links of this video across all your social media platforms. Begin to do it now. Question 4. We have y equal to sine cube. We have this. So that's what we have. Okay. Actually, you can use product rule for this, but if you want to do that, it's going to waste your time. It's going to be cumbersome. It's going to waste the time. Okay. So this is for our 3. The best way is to use a chain rule. We can write this question as this. We can write that. Okay. So if you like, you can make a substitution for the base. That will be V3, where V is equal to what? Sine x. Make a substitution for the base. Okay, then y now is now a function of v, so we can get the y, the v, which is equal to what? 3v squared. At the same time, v also is a function of x, so we can get the v, the x, which is what? Cos x. When you differentiate sine, it's going to give you cosine. Okay, then final conclusion, your dy, the x will be equal to the y, the v times the v, the x. And don't forget what I said, that whatever that is here must be here. Make your substitution. That will be 3. Your v is what? What's the v? V is sine square x, and then times what? The v dx. That's a cos x. And that finish question 4 also. For number 5, we have tan cube 3x minus 4. That's number 5. Tan cube 3x minus 4. Okay. How do we solve it of this question 5? I said we're going to liken this question to this format. Okay, and the format is what? You are having g of x inside f. Okay, g of x is an inner function, while the f is an what? Is an external function. So you have a function inside a function inside a function. That's the same thing happened here. Okay, you have a function which is 3x minus 4 inside tangents. Okay, so if you want to differentiate something of this nature, it's going to be the external function. You differentiate that while you keep the g of x constants. Okay, you keep the g of x constants, then times what? Derivative of that inner function. That's how to do that. We're going to apply that shortly. We're going to apply that shortly. Okay, if you're yet to subscribe, do that now. If you're new on the channel, okay, subscribe straight away. If you're new on the channel, subscribe straight away. Begin to give the videos a thumbs up. Begin to give this video a thumbs up. Begin to give it a thumbs up. Okay, give the video a thumbs up. Thank you for doing that. Thank you for doing that. Thank you in ways. And the first way, I think the fastest way, is to differentiate. Let's follow this procedure. Differentiate the outer function. Differentiate tan. Okay, and I'm going to differentiate the tan. It's going to be this will be 3 will go to the front. Okay, and then tan what? Tan the power minus 1, then 2. Don't forget the function 3x minus 4. Okay, so we've done that. And don't forget, we are going to differentiate the base, and that'll be what? Sec. If we differentiate tan, that'll be sec squared, the function, and then finally times derivative of the composite function, which is 3x minus 4. I'm going to solve it in 2 ways. Okay, so the final conclusion, if you differentiate this one, it's going to give us 3. So that'll be 3 times 3, that's 9. That's 9. And then tan square the function 3x minus 4, and then followed by sec square the function 3x minus 4. Okay, and that is that on this particular question. That is that on this particular question. I'm going to solve it in another way. Okay, if this one is not clear to you, we're going to solve it in another way. Begin to type I as you are coming in. If you are new on this channel, please subscribe right now. so that you can be part of the participants. Okay? Begin to do it right now. Invite your friends, invite your classmates, send the links to your friends, your classmates, send the links of this video to your classmates. Let's bombard the comment section with the questions, the greetings, the comments. Let's do that right now. Another way we can solve it, is we're going to do something now, is to rewrite this question in this form. That will be 3x minus 4 all to power what? All to power 3. Okay? That's the first step. I'll say y is equal to tan. How can we make it now? It's somehow fun. Okay, you can make it make this one tan v. Don't forget your exponents, your power is equal to what? 3x minus 4. We can do it that way. Just substitute for this the composite function. Then y is now a function of v. Okay, so we can now get the y, the v, which will be equal to what? The 3 will go to the front, and that would be what? Tan. Don't forget, that will be tan square v. The 3 minus 1, making power 2. Okay, and again, this is a chain rule. This is a chain rule, and then times derivative of that base, tan v. Okay, and then the v is the functions of x, the v dx, that's the 3, and derivative of tan is sec square. So that will be 3. Derivative of tangent is sec square. The v function is what? Is 3x minus 4, and then tan square. Your v is 3x minus 4, and then the v dx is what? Is 3. So 3 times 3. So this will be what? This will be 3 times 3. That's 9. That's 9. So that's that on this particular case. We can liken this question to this form, d dx of f of g of x. You can do that, and this will be equal to, you differentiate the outer function first, while you keep the inner function, the composite function, constants, and finally times derivative of the what? Of the composite function of the inner function. So that's what we're going to do here. We're going to differentiate the sign first. That will be cos of the function plus 3x, 4x squared plus 3x, and then times derivative of the composite of the inner function. I'm using prime for that differential coefficient. Okay, if you differentiate this one, it's going to give you derivative of 4x, that's 8x. Derivative of 3x, that's plus 3. And then times what? Cos 4x squared plus that 3x. And that ends that question. It's very fast. Okay, wisdom is the power. Wisdom is the key. So you can be wasting time and be sweating on this question, wasting time. Okay, when you are solving question, time is so precious. Time is very, very important. Okay, please, if you solve it the longer way and someone that just solve it in 2-3 lines, you get the same answer. Okay, this person has saved energy, and they have saved time. Okay, begin to say I as they're coming in. They are new on this platform. Okay, subscribe right now. Do it now. Okay, now is the time. Do it now. Subscribe now. Okay, not only that, but also begin to share the links of this video across all your platforms, on your Facebook, your Twitter, all your platform. Send the links across. Okay, thank you for doing that. Thank you for doing that. What we have here is this question: why x minus 1 over x plus 1 all to power 4. Okay, to avoid confusion, to avoid mistakes, to avoid an error, the best way to do it is to give this fraction, give it a letter. Okay, call it a letter. Give it a letter where your v is what? X minus 1 over what? X plus 1. It makes it easier. Give that fraction a letter to avoid making mistakes. Okay, give it a letter to avoid making mistakes. Then the next thing to do now, we're going to y now is the functions of v. So the y, v is equal to 4v to power 3. V is the functions of x. We're going to do the v, the x. But this fraction, when you have a function, okay, that involve a fraction that has the upper and the lower, it has the numerator and denominator, okay, and you want to differentiate such, this call for what we call quotient rule. When you have a fraction function, okay, and you want to differentiate, this call for what? Quotient rule. You apply quotient rule. So quotient rule is very simple. What's the formula? The formula is what? V, the u, the x, minus u, the v, the x, over v squared. Your v is your denominator. Your u is your numerator. So let's quickly apply that. That will be equal to what? That will be equal to my v is what? X plus 1. The derivative of the numerator is 1. That's my du dx. Then minus my u is what? X minus 1. The v dx, that's the denominator. Derivative of the denominator is also 1 over the denominator square. And we don't bother, we don't expand the denominator. Just leave it that way. Okay, leave it that way. Can we do the expansion for this? So this will be x plus 1. Allow this minus to enter these brackets. That will be minus x. Minus times minus, that's a plus. Over what? X plus 1 or 2. So minus x, this one and this one we can see. So we have 2. We have 2 there. So our dy dx is equal to dy dv times dv dx. So we can make substitution. The v is 4v cube, and then times the v dx is what? Is 2 over what? X plus 1. 2 times x plus 1 squared. Okay, the x is equal to, my v is what? Now 4 times v is x minus 1 over x plus 1, and then times this one power 3 times 2 over x plus 1 squared. Okay, x plus 1 squared. So we can pull it together. 4 times 2, that's 8, times x minus 1 to power 3, x plus 1 cube, times x plus 1 squared. That's x plus 1 power 5. And that ends that question. That ends that question. Okay. Please share the links of these episode on Chiru Pachu across your social media platform. On this note, I want to say thank you for joining this live session. Keep watching, keep liking this channel, and keep broadcasting this channel. Make the channel to go viral. Okay, thank you for doing that. See you again in the next few hours on this channel. Thank you. Bye bye.